Hello everyone. Today we'll discuss about the biochemistry of the isoenzymes. Now first of all, what are isoenzymes? They are actually the physically distinct form of particular enzyme of same activity. Means the activity, the function of particular enzyme would be the same. Okay, but they would be physically distinct from each other. Okay, actually they are the multiple molecular form of a particular enzyme. Means a particular enzyme will have different forms or different physical structure and different molecular structure, but their activity, function, importance would be the same. Now for example, let's take an example of 1 rupee coin. Okay, just take 5 to 10 1 rupee coins. Okay, and when you will examine it carefully, you will be able to see that each and every 1 rupee coin will have some of the difference in their structure or the lookings, right? There will be minor variation of ridges on the rims and number of dots below the ears. Means they will be different in the structure. Okay, but their importance, their value in the market of each and every 1 rupee coin would be of the same value or the same face value. Okay, but when you will examine it carefully, you will be able to see different structures, right? So in that, the function, the activity of the particular 1 rupee coin will be same everywhere. Each and every 1 rupee coin may have difference in their structure. So similarly over here, each and every enzyme of a particular isoenzyme would have the same function. Okay, but minor changes may occur in the structure of the particular enzyme. Now we have two things over here, homomultimer and heteromultimer. Now if the subunits are all the same, means if the particular enzyme is made up of all the same subunits, okay, that is known as a homomultimer. And what is heteromultimer? So of course the subunits will be different in a particular enzyme, so that is known as the heteromultimer. Now what is the importance of this particularly studying of this isoenzyme? Because we know the functions are same, so what is the need to study this particular enzyme known as the isoenzyme? Because the study of isoenzyme is very useful to understand the disease of different organs. Means because of the different structures, okay, though the functions are same, okay, but because of different structure, what kind of disease they can cause to a particular different organ can be identified by this particular isoenzymology. Now the isoenzyme may be formed in different ways. Now first of all, it is a true isoenzyme. Now what is this? It is actually the true isoenzyme is the product of different gene, and as because they may be located on different locus in the chromosome. So means different gene form a different gene and may locate in the different locus in the chromosome. For example, saliva in the pancreatic amylase. As you all know that the function of this particular amylase is the same, right? But because of a different location, okay, they actually form the isoenzymes. Now next is all different forms are present in a particular individual. Means sometimes what happens is in certain cases all the different forms of a particular, means all the different isoenzymes, okay, suppose a particular isoenzyme is actually having different forms of it but the same function, so that particular isoenzyme, all the forms of the particular isoenzyme may be present in a particular individual, and the best example is the LDH, lactate dehydrogenase. Now you may know that this particular LDH is actually having 5 isoenzymes, okay, and these all 5 isoenzymes are actually present in all individuals, okay, on the earth. Okay, means all the people on the earth would be having the LDH and all the isoenzymes of LDH. That is, we have LDH1 to LDH5 of the particular LDH enzyme. Now they are basically H4, H3M1, H2M2, H1M3 and M4. These are the 5 isoenzymes of LDH. We will discuss about the isoenzyme of LDH particularly in this video only later. Now next is the allo enzymes. Allo means alternative forms. Okay, so it means different alleles will be particularly present in a particular locus. Means same location in the chromosome, same locus on the gene on the chromosome, but that particular locus in the chromosome will have different alleles that will actually characterize the particular isoenzyme. For example, G6PD present on the location is the same, X chromosome, okay, but because of the change in the allele, because G6PD have around 400 isoenzymes in them, so you can imagine that particular chromosome would have a particular location, and in that particular location there will be variation in the alleles in a particular location of the locus of the chromosome. The example is G6PD of allo enzymes present on the X chromosome having different alleles. Now we have one more form known as the isoform. Molecular heterogeneity of enzymes may be produced after protein synthesis, means after the post-translational process, means in the post-translational process, means when the proteins are completely produced, okay, after that there will be some of the molecular changes that will occur in the particular isoenzymes known as the isoforms. For example, sialic acid content in the ALP. ALP is the alkaline phosphatase enzyme. Okay, so after the production of particular protein in the enzyme, there will be changes in the particular molecular structure of the particular enzyme after its formation. So that is known as the isoform. So true isoenzyme, that means the particular isoenzyme would be having different forms in the way of having different gene at different locus of the particular enzyme. Okay, of the particular chromosome. Now next is that all different forms of the particular enzyme will present in all individual on the earth. That means LDH is actually having its 5 isoenzyme forms, right? And all the 5 isoenzyme form actually present in the all individual on the earth. Now next is the alloenzyme. Allo means alternative form. It means different alleles present in same locus of the gene of the chromosome. Example, G6PD, glucose 6-phosphate dehydrogenase, present in the same locus X chromosome but having the different alleles in the particular locus of the chromosome. Now last is the isoforms. That means molecular heterogeneity of the enzyme produced after the protein synthesis or the post-translational process. Example, sialic acid content in the ALP. ALP is the alkaline phosphatase. Now next is the identification of the isoenzymes. Now how we will able to identify different forms of isoenzymes? So we have this much methods. First of all, it is the electrophoresis. Now what happens in this? In agar gel or polyacrylamide gel, electrophoresis is done, and the isoenzymes in that particular gel electrophoresis will have different mobility, and according to that we will able to find the particular or identify the particular isoenzyme. For example, in the isoenzymes of LDH, I told you before only, in the LDH we have total 5 isoenzymes present in all the individual, and all these isoenzymes are present in all the individual on the earth, on the human being's body. So now these are the 5 isoenzymes in LDH: L4, H3M1, H2M2, H1M3 and M4. Now according to the mobility we have differentiated them, okay, because of the difference in the mobility of them. Now remember, this H is mainly present in the heart and M for muscles, okay, but because of the change or the molecular difference in this, or molecular structural difference in all these isoenzymes, they are actually different from each other but having the same function, that is lactate dehydrogenase process. They will convert lactate into pyruvate. Now next is the CK, means creatine kinase, and ALP means alkaline phosphatase. Now next is the heat stability. Now one of the isoenzymes may be easily denatured by heat, and the examples are bone isoenzyme of ALP, BALP, bone isoenzyme of ALP. Now inhibitors. Now one of the isoenzymes may be sensitive to one inhibitor. For example, tartrate, labile, ACP. Now the Km value. Now particular isoenzyme have different Km value as compared to the other. For example, glucokinase has high value of Km as compared to hexokinase. Glucokinase has around 10 millimoles per liter of Km value, and hexokinase has around 0.05 millimole per liter of Km value. Now next are the cofactor. What is cofactor? Cofactor, that means isoenzyme and metalloenzyme are the actually considered as cofactors. Now the cofactor requirement may be different for different isoenzymes. For example, mitochondrial isocitrate dehydrogenase is dependent on the NAD. Okay, is actually NAD dependent, but the cytoplasmic isoenzyme, okay, is NADP dependent. So the cofactor NAD and NADP are different in the particular different isoenzyme. Now next is tissue localization. Localization of tissue may be different for particular different isoenzyme. For example, as you can see, I told you before, only H4 and M4 are these are the isoenzymes of the LDH. So H4 form of LDH is present in heart and M4 in the muscle. And the last is the specific antibody may identify different types of isoenzyme. For example, CK means creatine kinase isoenzyme are separated by the use of antibodies. Now we'll discuss about the lactate dehydrogenase in particular in detail. Now first of all, the isoenzyme of LDH. Now what are the isoenzymes of LDH? Now remember, first of all, the LDH is a tetramer having 4 subunits, and in that 4 subunits we have H and M polypeptide chain. Okay, in that 4 subunits we have H and the M polypeptide chain. Now although both of them have the same molecular weight, 32 kilodalton, there are minor amino acid variation in these 2 polypeptide chains, that is H and M. So difference in the very minute variation in the amino acid in this particular 2 polypeptide chain, there would be different forms of isoenzymes in this particular LDH. So now it will form, because variation in the different places of amino acid, there will be 5 combination of H and M are possible in the nature. That is H4, H3M1, H2M2, H1M3 and M4. Now we discussed before only that these isoenzymes can be separated by the cellulose acetate electrophoresis in pH 8.6. Now the bands are identified by adding the reactants containing nitro-blue tetrazolium, producing a color reaction to be quantitated by a scanner. Now these are the 5 isoenzymes of LDH 1 to 5. Name accordingly. Subunit makeup of isoenzyme are H4, H3M1, H2M2, H1M3 and M4. Now according to the electrophoric mobility at pH 8.6 in the particular cellulose acetate electrophoresis method, the fastest one is the H4. I told you before, this is the diagram. So H4 will be the highest. Then as soon as this will go down towards the M4, the mobility will particularly decrease. Fastest, faster, fast, slow and slowest. Now activity at 60 degrees Celsius for 30 minutes. So these first two LDH are not destroyed. Then LDH3 is partially destroyed and the next two are destroyed at 60 degrees Celsius for 30 minutes. Now tissue origin, very important. LDH1, I told you before, only having these all isoenzymes are mainly for muscles and the heart only. But because of their amino acid variations, they are actually having different forms or isoenzymes. So for sure H4 is for heart, so of course in the heart muscle. Then H3M1 in the RBC brain, H2M2 in the brain leukocytes or WBC, H1M3 liver leukocyte and M4 for skeletal muscles. Now percentage in human serum is this much. Now LDH isoenzyme in disease. Now we all know LDH is mainly used to convert pyruvate into pyruvic acid and normal serum value is 100 to 200. And the H subunit in this, H subunit is actually for heart muscles, while M subunit is for the skeletal muscles. And remember, normal value of LDH2, this H3M1, normal value of this concentration in the blood is, remember, always greater than LDH1. This value is actually greater than LDH1 in normal healthy human being. Okay, but this pattern of LDH2 more than LDH1 is flipped in the myocardial infarction. So in the myocardial infarction, the value of H3M1 is less as compared to the H4. So means in myocardial infarction, the LDH2 is less as compared to LDH1, and so that pattern is known as the flip pattern, because normally in the blood H3M1 or the LDH2 is more than the H4 or the LDH1. Okay, but this is reversed in the myocardial infarction. Now remember, in myocardial infarction, total LDH activity means total LDH activity of all this isoenzyme is increased. The H4 isoenzyme is actually comparatively increased around 5 to 10 times more as compared to normal healthy human being. Also the LDH level will start to increase by, remember, 6 to 12, LDH increases by 6 to 12 hours, reaches at the peak at 24 to 48 hours and normals at 6 to 8 days. Now LDH level is 100 times more inside the RBC as compared to the plasma. So just think that if there will be hemolysis of RBC, so what will happen? The amount of LDH will actually increase in the plasma also, in the blood also. So what will happen? It will give us negative value or negative positive value, the false positive value of LDH, though there is not particularly myocardial infarction occurring in the body. In the hemolysis, what will happen? Whatever amount of LDH is present in the RBC, that means 100 times more, will be come out in the blood concentration and will show false positive value or false high positive value in the test of this particular LDH enzyme in the blood. So it can give this particular LDH enzyme level can give us false positive value. So LDH is not used as cardiac marker nowadays. So this was all about the isoenzymes in the enzymology. So hope you understood well. Thank you so much.